do is I wanted to double check to see, okay, is it going to be curved in these corners or in these corners? So I put it to the calculator, x in the numerator divided by x plus 1. Okay, so that's what that is. So I put it into my calculator, and when we graph it, it looks really funny because those asymptotes throw it off. But what it does show me is that it curves actually in this section, and it curves in this section. And the reason why we're finding the asymptotes is because we're finding out what these lines are right there. So this is really, it looks really funny, but it tells us that it curves here and it curves here. And so it actually looks better if we do it ourselves, but the calculator told us which corners we should be drawing. So we take our marker, we decided, okay, or our pencil. We decided, okay, it should curve in this corner, and it should curve in that corner. All right? And you just have to do a general curve. It doesn't have to be perfect. That's just the shape it looks like. These are telling us those boundaries. So then here we want to actually do what we already have done before when it comes to any sort of function, any sort of polynomial stuff. And that is, this is our end behavior. As it goes to the left, what is the function doing? So as we go left, okay, what is the function doing? All right, so as it goes left, the function is approaching which number right here? Okay, well, we decided that's the number 1, so the function is approaching 1. Because it's going to come close to 1, but it's never going to touch it. Okay? And then, as the function goes right, so if you notice, this arrow is the one that's going right. Okay, what is it approaching? What is this this y value that it's approaching? It's approaching the number 1. So this asymptote relates to, that asymptote relates to what the function is doing. As it goes left, it approaches 1, and as it points right, it's also approaching that 1. Okay? It's a little bit different than what we're used to, but we'll get used to it. Okay? And then increasing and decreasing. Well, where is it decreasing? If you go from left to right, where is it pointing down? And if you notice, it's not. If you go from left to right here, it's constantly pointing up. If you go from left to right on this one, it's constantly pointing up. So there's actually no decreasing. Okay, but they're both increasing. So as we go from left to right on this one, we're going from negative infinity, and then where is it coming close? It's coming close to the number negative 1, because remember this dotted line stands for negative 1. Let me write that. All right, let me write that here, because remember it's the x value. So as this one's going from the left to the right, it's going up from negative infinity to negative 1. So that's one of our increasing. And then we put it in union with the other one. So here it's coming from the left. It's coming from this dotted line right here, which if you think about it, again, it's negative 1. But then it's going to point forever to the right, which we know, I don't know if you can see that, which we know is positive infinity. All right, so this side is going from the asymptote, the boundary line, from negative 1 out to positive infinity. So this increase is telling us it's going up in both of these intervals, but there's a break. There's a break between that negative 1. It doesn't actually hit negative 1. It stops at negative 1 on this one, and it starts just past negative 1 on that one. But these negative 1s, that relates to the vertical asymptote, and then these positive ones, they relate to our horizontal asymptote. Okay, because this represents our y value, and these represent our x value. All right?